out during your group preparation session.
Yeah.
So I don't know. I didn't do that part, but
I pre-did it, but that's just because I don't know. I was scared we'd get into it and struggle, so I thought, I'll pre-do it. And then if we have questions, we can talk about it. But however, it doesn't matter to me.
no, shouldn't it? Doesn't. Was it very difficult?
No.
Okay.
I actually did it harder than it needed to be, and then I went, why did I do it that way? So I actually learned a shortcut on how to do it a little quicker. Perfect. And then because I try to do the homework first and then watch the video on it.
Yeah.
If that may answer my questions. The hard part about the video is it actually didn't. It talked about similar problems, but they weren't the problems. So I was like, okay, that's a little weird, but hey, whatever.
Whatever works.
Yeah. Let's see, just checking. Still no emails from, what's his name? I forget his name. Well, we might as well get started then. If he joins us in the next couple minutes, he won't miss much. So,
I mean, the meeting was supposed to start at 5 anyways, so.
Yep, I agree.
Anyways, I don't know. I mean, we'll figure it out, hopefully.
That works for me.
Right. So do you want to start, or do you want me to start?
Sure. No, I can. Doesn't matter to me. However. Okay. So part 1, use the information in the reading assignment to complete these questions. What notation is used to denote the probability of an event occurring? So I'm just arranging my screen so I can read and look at the same time.
Yeah, no worries.
So P times X is the notation that we use to describe it. So P and then in parentheses X, but it's P times X.
That's what I got too. All right, for number 2, please state and describe the 3 rules of probability. So I kind of got this one directly from the text, but rule number 1, the probability of an event X is numbered between 0 and 1. Rule number 2, if you list all the outcomes of an experiment, the probability that one of these outcomes will occur is 1. In other words, the sum of the probabilities of all the possible outcomes of any experiment is equal to 1. Rule number 3, the probability that an event X will not occur is 1 minus the probability that it will occur.
Yeah, very good. That's what I got too. So, number 3, what does it mean to be random? And I have, we can't predict the next outcome.
Yeah.
There was quite the explanation in the video on it, but I think that kind of summed it up pretty good. It's just that there's no way for us to completely predict. I mean, we may be able to, with a 6-sided die, we may be able to say it's going to be one of these 6 things, but we can't predict it. We could guess, but that's not a prediction. So.
Yeah. One thing that I thought was interesting that I didn't know when I was reading was just one of the sentences where it said any random process follows a very distinct pattern over time. So like when it says, oh, 1 out of 6 times you'll get a 1, on a 6-sided dice. It's just because over time eventually it evens out. So it's like random, but it's not, like over time it's not random, if that makes sense.
Yep.
So it's like you were just saying, it's like hard to pinpoint, like it's just kind of random, for lack of a better word. But over time, I didn't know that. I didn't know that eventually it becomes kind of like a pattern, which is interesting.
Yep.
All right. Number 4 is, what does the phrase discrete random variable mean? So it's kind of like it's a variable. A variable is random if the values follow a specific distribution. So kind of like I was just saying, in the long run, they're going to follow the same pattern. So that's what makes it random. And then it's basically if the values can be listed given enough time. So like eventually it will become eventually it'll become able to be written down. I don't know if that makes sense, but
Yes.
I'm having a
Yeah,
hard
it
time
does.
putting it into words. But it's kind of like it's random, but at the same time, if you give it enough time, you'll be able to sense the pattern. So eventually, you'll be able to write down that, a 3 will come up on a 6-sided dice, 1 out of 6 times. That'll be eventually what it is. So
Yep. That's what I had too.
okay. And then the ones I didn't do, but
That's okay. We're supposed to do them now, so no big deal. We're okay. So for 5, it says an 8-sided die has 8 possible outcomes for each roll: 1, 2, 3, 4, 5, 6, 7, or 8. Calculate the probability of rolling a number greater than 5. So this one, to me, all I did is I said, okay, if you've got 1 out of 8 chance of rolling a given number, which is 0.125 of a probability,
yeah,
I just said, okay, if they want greater than 5, so that's 6, 7, and 8, I just added 0.125 together 3 times and got 0.375. The
yeah,
other way you can do it is just divide 3 by 8 and it gets you the same number. So it's kind of math where you multiple ways to do the same thing, how, whatever's comfortable.
okay, that makes perfect sense. Thank you so much.
And then 6 was pretty much just the opposite, because all you're doing is saying, okay, calculate the probability of not getting that number that's greater than 5. So then you've got 1, 2, 3, 4, and 5. So you can take 5 and divide it by 8, which gave you a 0.625. Or, and in my case, I just subtracted the 0.375 minus 1, which gave me the 0.625. So some of that's just that math where you can, do things different ways. But
Yeah.
overall, really easy.
What you did on the second question of subtracting it by 1 meets rule number 3 of probability, which is the probability that event X will not occur is 1 minus the probability that it will occur. So
Yep.
you did that, by the book, to put it in a good term. So good job.
And
That's
the guy on the video, he shows putting this big chart together, and I'm like, we have to do all that? So I kind of followed him through and did the whole chart, and then at the end, I realized it was a different problem than what we already had.
yeah.
So I was like, okay, well, that was, I don't want to say a waste of time because it showed me how to do a few things, but you just kind of go, okay.
Didn't
So
need
if you watch that video, just realize the question's different because it only says a 4-sided die, and then he comes up with like the variance and the standard deviation and stuff, and that's not what our questions ask. Well, I was like, okay, well, all right.
So you said you did the homework, right? Have you done it already?
No, not the for this lesson. I haven't done this homework yet. I still need to. That's on my list for after our meeting. So
yeah, that's on my list for after our meeting too. So all right. Let's see here. I guess we are on to the next part, right? The quiz.
Yep.
I'm wondering where Michael is.
Yeah, I wonder if you joined a different group and just forgot to mention it, or I don't know.
Maybe. Let's see here. So we are in.
Looks like there's only 13 questions this week, or this quiz anyway.
How did you do on the homework quiz of the second section that we did?
I think I got a 90 on that one. I took it the first time, I think I got an 80, and I took it the second time, I got a 90.
Yeah, so the first question really stumped me.
Yeah.
But then I figured out the reasoning, like why it was wrong, and then I got it right the second time.
Oh, right.
Because like if the graph's right skewed, then the mean will be greater than the median, if that makes sense.
It does.
So
yeah.
the one that was that was right was the mean was like 11 or something like that. But all right, sorry, I'm just really behind right now. My computer's being slow, and I'm trying to explain things that you probably don't remember. So
no worries.
Let's start this up here. Did my individual. Okay. Question number 3. Do not give probability answers as percents. Okay, that's good to know.
Yep.
Okay, I'll start with reading number 3
Okay.
for the first, explanation. So,
Sounds
human
good.
blood can be classified into one of our basic types, O, A, B, and AB. The proportion of the people in the population in the United States with each of these blood types is summarized in the following table. So question 3. The blood types and the proportions given in the table define a probability distribution. Okay, I assume that it, let's see. Wouldn't it be defined as a probability distribution if they all add up to 1? Is that
That's
kind of
my
the
understanding.
rule of thumb? Let's see. Yeah, it looks like they add up to 1. So my gut's saying to go with true, but what do you think?
That's what I was thinking too.
Okay.
All right, question 4. What is the probability that a randomly selected person in the United States has type O blood, rounded to decimal places? Well, according to this, 45% of the people in the population have type O blood.
Yeah, I mean, I don't know if I'm overthinking it, but I feel like the answer should be 0.45. But
That's exactly what I was thinking too.
because I mean, if it says in the example that the proportion of people in the population of the United States with these types of blood are summarized, so it should be 0.45.
I
But
agree.
probably find out soon that it's not. Hopefully not, though. So what is the probability that a randomly selected person will not have type O blood? So in accordance with what you taught us in your explanation of the last question in preparation, if you just subtract 0.45 from 1, see what that answer is. Or if you
0.55.
just add, yeah, 0.55, great.
Yeah.
So that's what I assume the answer would be.
I'm with you there. That makes sense because realistically, if we added the rest of them together, that would give us that number too. So,
yep. Just easier to do 1 subtraction rather than 3 addition, right?
I agree. Yeah.
Or, yeah, 3 addition. Okay.
Okay.
Let's go on.
So, Carolyn Willis and her colleagues conduct a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine, bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. One of the samples came from a person identified as a bladder cancer patient. If the dog guesses at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? Okay, so 7 total, right? 7
So it's
bowls.
1 divided by 7, right?
Yep, exactly. Which is,
0.143.
yep, that's what I got. Down to 3 decimals, so yeah.
Okay, question 7. In a combination nide, that's what I almost said. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer, and there is little evidence that dogs can detect bladder cancer. So that's like just below 50%, right? Maybe a little bit more than just below, but 22 divided by 54,
Yeah, 49%.
yeah, 40% is what. So, I mean, that's pretty high. But I don't know. I guess
This
if,
one is where you wish you could ask it, say, okay, because to me, at 50%, if you got 50-50, I mean, this provides pretty strong, in my opinion, evidence that these dogs can detect it. But then again, 50% of the time they're missing it too. So
yeah, 54, let's do 54 divided by 7, right? Because that's how many chances they have.
mhm.
So it's like 7. So they have, let's see, because if they have 7, it's 7.7 chances to guess, right? And the probability of guessing every time is 1.4
Right.
or 0.14. So
0.14, yeah.
maybe if we added those together or times 0.143.
Because we're saying there's 7 bulls in each of the 54 trials,
Yeah.
and they picked it. You know, they picked 22 bulls that were correct out of the total.
Yeah, I
You're
don't
talking,
feel like it's pretty good evidence that they can detect bladder cancer, but that sounds weird to say.
mhm.
What do you think?
And the thing that gets me is this: the bottom one says there's little evidence. I think there's pretty good evidence personally that it works. So I think we're okay to put this provides strong evidence. That's my thought.
Yeah. And if our teacher's watching this recording, he'll probably not like me for saying this, but if we do miss this question, there's only a 50% chance that we'll get it, right the next time. So we'll be okay.
Exactly.
The probability of us getting this right is 1 out of 2. So I think we're
Yeah,
all right.
I think you're 100% correct there.
Just using some probability humor.
Yep.
All right. So M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of the colors in the bag of plain M&Ms are given in the following table. Is it just me or is the green one locked out there?
Yeah, it is on mine too. It looks like it's scribbled out.
So question 8, if you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy? Well, I assume it's 0.13.
That would be my assumption too. Now, my question is, because without that green there, do they equal 1?
That's what I'm adding up here.
And they don't.
So added up all together is 0.64.
Oh, I got 0.84. Did I fat
Wait.
finger something?
Maybe I think I did it wrong. So let me try. Yeah, it's 0.84 because I forgot to add the 0.20.
Oh, yeah.
Sorry about that.
No, you're fine.
So
And
that
I
leaves
regardless, I think it doesn't matter just because if you're reaching in, even with green,
Oh.
you still have that 0.13 chance of getting a red one, right?
Yeah. It looks like we were getting ahead of ourselves because the next question says, what is the probability that a randomly selected candy is green? So
Oh.
it would be 0.16, which
Yeah.
is the remainder. So
Up to
I
that
guess that
1,
is our
yeah.
answer because the 0.13 is our answer because they wanted to test to see how we would respond. So a
We'd
candy
overthink it
that's,
at all.
yeah. So then question 10 is what is the probability that a randomly selected candy is not green? So that would be the 0.084 that we added up, or that you added up correctly, not me because I didn't.
0.84, yeah.
0.84, yeah. All right. On to the next one, I guess.
Okay. The ACT scores of the students admitted to a medium-sized public university in the Western United States were taken from capex.com. The following summary statistics were calculated. Okay, so those are mean, standard, variance, all that. Half of the observations are less than or equal to what number?
Would it be 24?
Well, that's your median, right? So, yeah,
Let's go with that and see what happens.
I agree.
Well, these are just review questions, but or at
Are
least
they?
these two are. They say
Okay.
review. I guess that's what they are. But then it says based on the information on the table above, the top 25% of the students scored above what number? So that would be the third quartile, right? So it'd be above 27.
Is it the third quartile or is it the first quartile?
It's the top 25%.
Oh, sorry, I was reading 25%.
So
Yes, I
yeah,
agree.
you're right though. If it did just say 25, it would be the first quartile, but
Right.
I think it's
But it
referring
says
to
top 25. So yeah, I agree. It would be the third quartile. So 27, is that what you're saying?
27, yeah. Because the top number that somebody got was a 35.
Was the high, right.
Yeah. All right, cool. Which of the fall? Oh, it's your turn. Sorry if you want to read that.
Oh, which of the following statements is not one of the three rules of probability? The probability that an outcome will not occur is 1 minus the probability that it will. A probability is a number between 0 and 1. If the probability is high, then the probability is positive. If the probability is low, then the probability is negative. The sum of the probabilities in any probability is 1.
Well, I think the probability is high that you're positively on. So I think that's probably the answer.
Yeah, I'm with you there. Sorry, I couldn't help but laughing even as we were working through it. So
Yeah, I mean, it was a funny answer.
mhm.
All right,
All
let's go
right,
ahead
so
and
that's all of them.
submit this and see what happens. Looks, I got 100 on my end.
I did too.
All right, sounds like we did a good job then.
Yeah, it looks like it. We didn't overthink anything. That's good.
Yeah. So I'm happy we got that one, the strong evidence one right, because
Yeah, yeah. That was just a weird question. Yeah.
Yep. All right. Well, I guess we'll
Cool.
go ahead and finish out this homework and then meet up on Thursday. Is that right?
Yep, that sounds good to me.
Okay. I'll be back at our normal time, so I'll see you
No
at 5.
worries. Yeah, no worries at all. Because I'm flexible, so don't feel
Okay.
like if we need to shove it a little earlier or a little later or whatnot, just shoot me a note. I'm happy to move. So
Okay.
no big
Sounds
deal.
good.
Cool.
All right. We'll
All
see you
right.
then.
Thanks, Hayden. Yep. Have a good night.
Bye. You too.